All right, let's take a look at 1.3 geometric sequences. To start with, we'll compare a geometric sequence to an arithmetic sequence. So here would be an arithmetic sequence. An arithmetic sequence would be something like 3, 5, 7, 9, dot, dot, dot. Our term 1 is equal to 3, and our common difference is equal to plus 2. We're adding 2 each time. If we were to graph this on a line, it would start, it'd be 3 here, there would be 3, and then it would go up in a nice line like that. A geometric sequence that starts at 3 now has a common ratio of times 2. Go 3, 6, 12, 24, dot, dot, dot. We get our common ratio just by dividing these two numbers. 24 divided by 12 is equal to 2. We could divide these two. 12 divided by 6 is equal to 2. 6 divided by 3 is equal to 2. This one graphs a little bit different. This one starts at 3, and then it goes up to 6, and then it goes up to 12, and then it goes up in a big, quick curve like that. So an arithmetic sequence gives us a linear equation, and a geometric sequence gives us a nonlinear equation. Now let's take a look at how to figure out the nth term of a geometric sequence. So this one, term 1 is equal to 3. Then term 2 is equal to 3 times 2. Then term 3 is equal to 3 times 2 times 2. Then term 4 is equal to 3 times 2 times 2 times 2. So look at how many times you multiply the common ratio into it. Well, for term 3, we multiply it. We do 3 times 2 squared, which is just that number minus 1. For term 4, we do 3 times 2 to the power of 3. For term 100, we would do 3 times 2 to the power of 99. So here's how we determine the nth term of a geometric sequence. The nth term is equal to our first term, term number 1, times our common ratio to the power of n minus 1. All right, these variables should look familiar to you based on the arithmetic sequences. The only difference is that we have a common ratio here instead of a common difference because we're multiplying. Now we're going to look at some examples in just a little bit, but let's talk about writing numbers in different forms. So we've got 3 main ways to write numbers: decimal form, fractional form, percent form. So decimal form would look like 0.5. Fractional form, which is preferable, this would be 1/2, and percent form is 50%. We generally don't use the percent form in mathematics. We usually use the decimal form or the fractional form. And I prefer the fractional form. So as another example, if we have let's say we have 2 over 3. This is equal to 0.6 repeating 6. And you can see this is difficult to work with because there's always more 6s. This is easy to work with because it's just integers. Well, this is about 66.7%. That's a rounded form. One other important fact that you need to know, that if we take a number and we times it by 1/2, that's equal to taking that number and dividing it by 2. Okay, this works for anything. If we take a number and we times it by 3 over 2, That's the same thing as taking that number and dividing it by 2 over 3. So our goal is to convert every division into multiplication so we don't have to divide. All right, so we are going to identify 4 different examples of geometric sequences. We're going to identify the first term, the common ratio, and the formula for the general term. So our first example. We're going to make our first term. Term 1 is equal to 2. And our common ratio is going to be equal to 3. So this is 2. Then this is our second term is 2 times 3, which is 6. Then we take 6 times 3, which is 18. Then we would do 18 times 3, which is 54, ... Now, the formula for the general term, we write this down. Term n is equal to, well, actually, I'm just going to write this down once for all of them. Term n is equal to our first term times our common ratio to the n minus 1. And when we want the general term, basically we're going to have this and this remaining as variables. So let's do that for this one. Term n is equal to 2 times 3 to the power of n minus 1. We cannot combine the 2 and the 3 together. That will not work. We have to do the exponent first, right? If we look at our brackets, exponents, division, multiplication, addition, subtraction, we have to do our exponents before we can do multiplication. So we have to solve this before we can multiply it to the 2. So this is the formula for our general term. If I want to find the 100th term, I would do term 100 is equal to 2 times 3 to the power of 100 minus 1. And Desmos will tell you that. Now, let's look at our second one. Our term 1 is going to be equal to, we'll say it's going to be equal to 100. What happens if our common ratio is not, sorry, it's 100. Our common ratio is 1/2. Now, our common ratio of 1/2 is the same thing as dividing by 2. Okay, so we're started at 100. We times it by 1/2 to get 50. We times it by 1/2 to get 25. We times it by 1/2 to get 12.5 and ... Now, I could also write 12.5 as 25 over 2 as a fraction. Then I don't have decimals involved. Now, let's look at our general term. Term n is equal to 100 times 1/2, and I'm going to put 1/2 in brackets to the power of n minus 1. Notice how this one up here was getting bigger. It was growing. This one here was going down. And this one, we're just going to keep dividing this in half and dividing it in half. This will never get into the negatives. It'll just keep getting smaller and smaller and smaller. Let's look at a third one. What happens if our term 1 is equal to, let's say, 5? What happens if our common ratio is equal to a negative number? Let's do -2. This means we're going to multiply by -2 each time. It means we start at 5, multiply by -2 to get -10. Then -10 times -2 is plus 20. Then -40. ... Notice how this one bounces around. We start at 5, then we go down, then we go way up, then we go way down, then we would go way up, then we go way farther down. It bounces around back and forth. So what is our common term? Well, it's our term 1, which is 5, times negative 2 to the power of n minus 1. And the negative needs to be in the parentheses because the exponent applies to it. One last one. Term 1, let's say term 1 is equal to 11. And our common ratio is going to equal negative 2/3. This is not easy to multiply out and get decimal numbers for. So we need to use fractions. First term is 11. Then we multiply by negative 2/3. So we get negative 22 over 3, right? Because our first term is 11 over 1. And we just take our 1 and times it by 3 to get 3. Take our 11 times it by negative 2 to get negative 22 over 3. Our next one, we're just going to multiply by negative 2 over 3 again to get plus 44 over 9. And our next one is going to be negative 88 over 27. So working with fractions can make things easier and easier. Now, if we look, this one starts up, let's say that this is our line of 0. Starts at 11, goes down here, comes back up, goes down here, comes back up. That's kind of how the graph of this would look. Now let's look at our nth term. It's equal to 11 times negative 2/3 to the power of n minus 1. So it'd be easy to find the 100th term for this. In the olden days when your calculators were not so good, this was kind of difficult to do on your calculator. You kind of had to learn how to do this. But with a modern calculator, you just type it in how Mr. Stein writes it, and your calculator should figure it out. In the next video, we will look at the examples.